something. All right, so I just got a little note up there. So you know what's going on with the time frame. Like I said, we'll finish up today, and then Wednesday will be review/test day. You don't have to take it in class. As a matter of fact, I mean, I don't know that that's really, unless that's the only time you got, you can just do it during that time. Because it's being recorded through to you recorded, you don't have to be on here to do it. So just recognize that, because the midterm week, it's over at the end of this week. It's just like sort of like an advanced preparation for the final exam, because the final exam happens at a specific time. The exam ends on a particular day, and then that's it. It's all gone. So don't think that thing is flexible. Let me get something. Because I got deadlines on entering grades, so I can't give any more time than what we got allotted right there. All right, any questions before we start? Like I said, we're going to be looking at this. If you got any questions, you can just pop them in the chat or yell them out. All right, so let's get started. All right, first off, on example 1, there's and these things are not created by me. They're created by committee, and so they're not always the most expedient way to do some these things. So I'll just explain to you how I feel, and then when we go over the other problems, after I give you a chance, I'll show you how I handle them. But the most important thing is that you understand what you're doing. All right, so we got two what's called monomials here. We got the negative 4x squared. I'm sorry, negative 4x cubed y squared times negative 6xy squared, okay? Well, there's a mistake on this too, and I figured that out last week. But with the way that we handle multiplication is we got to multiply things. Like for example, negative 4x cubed y squared, that first term, those things are all being multiplied together. And we know they're being multiplied together because that's generally the way that you write those kind of terms. A variable sitting next to a number like that on the left, that just means you got negative 4x cubed, and there's also a y squared. It's negative 4x cubed y squared. Once we found out what x and y was equal to, you could fill those in, and the way you would simplify that is to multiply. That's all that really means. So what they're doing here is they're taking one term and multiplying it times another term. So the way that we handle that is with numbers. We know how to do that since chapter 1. It's negative 4 times negative 6 which is right here. And like I said, this is kind of a sloppy way to write it with that dot. I don't know why they just didn't go ahead and put an extra set of parentheses in there. But that's -4 times -6. And here's the mistake. That should be positive 24. Positive 24. Now, with the variables, this is using that product rule that we just learned last week. X cubed times x, right there. When we multiply like bases, which these are x's, that's x cubed and x to the 1. So 3 and 1 is x to the 4th. And then here, y squared times y squared, 2 plus 2 is y to the 4th. And there we got it. Like I said, that's just supposed to be positive. It's a mistake. All right, let's go to the next one. Well, first of all, any questions about that? Like I said, that's a mistake. That should be, I can't fix it on this. Once we get over on this one, we'll be able to do that. I'm going to put this in there and I'll have it ready when we're ready for it. All right, now we're multiplying a monomial, that 3x. That's 3x right there. It's kind of hard to just isolate it with this. Times 2x squared minus 5x plus 9. So that means we're multiplying, like these arrows show, 3x times the 2x squared, the 3x times the -5x, and the 3x times the 9. And they're showing you all those little steps in there. Again, there's not really any need for the dots there. If you got the parentheses, those would be the same thing. So it doesn't hurt, but like I said, it is. So 3 times 2 is 6. X times x squared, that's x to the 1st times x squared. 1 and 2 is 3, so 6x cubed. 3 times -5 is -15. X times x is x squared. 3x times 9 is 27x. There are no x on the 9 term, so there's nothing that happens to the x. It doesn't change. It's still a single value of x. All right, questions? All right. So number 3, this is a binomial times a binomial. Now, some of you probably heard this term, that FOIL. It's nothing magic about it, just what the FOIL means. First, outside, inside, last is just using a particular order so that you get both of the two terms in the first expression times the two terms in the second one. And the FOIL is a new way to do. It's one way to do that. As long as you have 4 terms where each one of them is the unique one, you're fine. But that's what FOIL is all about. So this right here is the FOIL, the F in FOIL. It's first times first, x times x. Just a little short arc right there. X times x is x squared. Outside the O in FOIL, x times -3 is right there. And then we write that as -3x. On the inside, it's -5 times x. So -5x. And the last, -5 times -3 is +15. Now, with these, what's usually going to happen is you're going to have 2 terms in the middle, at least, that are going to be the same. There'll be like terms. In other words, there's -3x and -5x. Those are like. So we combine those. So -3 and -5 is -8x. Okay. All right, so questions? All right, so what I'm going to do is, let's go over here. And like I said, I'm going to fix this for you here just to let you see it. So it'll be right on the screen. All right, so that's what should be positive 24 because it's negative times a negative. All right, so let's move on down. I want you to look at those three, and I want you to start working on them. When you get some kind of answer, let me know some kind of way. All right, how we doing? All right, we getting anything? All right, let's see. Good, that looks good. All right. I'm just going to show you some extra steps. If you don't need to do this, this is fine. All right, that's what you're doing with the numbers. And then you got an x times an x. And then there's no y term in the first one, so that y is just going to come along for the ride. All right. So that's -20. And as I said, this is 1, and that's a 1. So when we use the product rule for multiplication on like basis, we add those ones up. Yeah. Good job, Krishna. All right. Anybody else got the same thing? Or got any questions about it? All right. So what else is going on? Anybody else got one for number 2? All right. So right here again, we got 2 times 5. And then we got x squared, x to the 6th. All right. So that's 10. And then if you just haven't caught on to this yet, the product rule, see it's 2 plus 6, which is how we get the 10 x to the 8th. All right, any questions? All right, so let's try this third one. All right, now this is sort of like the one that was messed up out there, so don't let yourself think that was a different rule. Remember, that's not supposed to be a negative. So two negatives make a positive. It's not a new rule. It was just a mistake on that worksheet. So each one of the numbers are multiplying each other, the x's are multiplying each other, and all the variables are using the product rule. So 72 positive, and then this is x to, again, I'm going to do the little intermediate step. All right. So just gander those. Tell me if you got any questions. Yeah, good. Valshon. Let's look on page 2 now. Okay, so concentrate on 4, 5, and 6. These are now monomials times polynomials. The first two, 4 and 5, are just binomials. The third one is trinomial. But anything more than 1 is called a polynomial. So. All right, so what's going to happen is 3x times 2x. And multiplying times both of them. Now, when you got this right here, I mean, you could put that negative in there and then handle it with whatever's out here. You're always safest to put a plus sign, and then you can change it later. Either one of those will work. So it's 3 times 2. And then x times x. And it's going to be negative. I'm just going to turn these around. So that's 6 x squared, because there's, again, x to the first, x to the first. All right, great. So go on and I'll give you a couple more minutes. right, so let's try it on I'm making some progress. Okay, so again, what you're doing is you're taking the negative 9x times the 6x. So we're multiplying twice. You remember we looked at division. When we multiply, did division, you do addition multiple times. Well, that's what you're doing here. You're doing multiplication more than once. So this is going to be negative 54, and it's x times x. So I'm going to assume now you know how to use that. If you don't, you can just ask. All right. Oops. Negative 54. Okay, great. All right, y'all are being real impressive. I like how we all are quiet, but you impress when you're actually doing your work. So that's what we need. All right, so the next one, you're going to have 3 of them, so it's going to be a little bit more tedious, so you got to watch out. Move over here so I got enough room. Again, I want to try to put as many steps as I can in. Squeeze this one in there. All right. All right, so let's go ahead on. Let's say. So it's 4 times 2. And it's x squared times x y cubed times y oops, so it's 3 and 1, so it's 1 to the 4th. Oops, that's going to be a negative. Positive times a negative, so it's negative 12. And x cubed, and then a y cubed. All right, and then 4 times 4 is 16 positive. And it's x squared, and there's no x on that side, so that x squared is just going to come along. And then there's y cubed times y, which is y to the 4th. Okay, good. I'll leave those up there. All right, now these are binomials times binomials. So this is where you can use that FOIL. I mean, it's not, that's just a monomic thing. All that just means is multiply the x in the first one times the x and then negative 11. And then the 4 times the x and then times the negative 11. All right, so remember, you just want to multiply everything. So you're going to have 4 terms. And all right, so let's look. So it's x times x. I'm going to try to put in thing here. Outside is x times negative 11. And I'm going to change the sign in a second. All right. So here's the first term, x times x. So that's x squared. X times negative 11, well, the sign's going to be 11. You know, the number always goes in front of the variable. Okay. And then these are going to combine. All right. So move ahead on to the next couple. All right. So it looks like a couple people got number 8. Let's wait to see if we get another couple of people. Let's see what happens. So it's x times 2x. That's your first. So x times 2x squared to the negative 9x is already pretty much done. We got to multiply the negative 6 times the 2, which is negative 14x. And again, there's your two like terms. You're going to come back. And then 7 times 9, negative both, is just going to be a positive 63. Oops, I got to combine those two. All right. So I'll give another minute on that. I got a couple of answers, but I want to see if everybody else wants to weigh in. All right, last one. So it's 3x times 2x. And then 3x just times a regular 3. And then on the inside, 7 times 2x. So 3 times 2 is a 6, and the x times x is x squared. And then you got 3 times 3 is 9x. There's only one x, so there's nothing to add on that. And then 7 times 2 is 14x. Plus 21. And again, unless these had a different variable, like if one had 3x and the other one had a 2y, which possibly could occur, they're just not that rare, they're kind of rare, then you're going to have those two that are going to combine in the middle. And it's another 23x, isn't it? What about that? So this time it's positive. All right. So any questions? All right. Let's take a little break, and then we'll talk about the rest of them. Like I said, this is the last ones. I think there's another sheet down here, or there's another set of problems down there, but we don't save those for afterwards. Okay. So I'll see you back in that quarter to. Okay. If you got any questions, let me know. All right. I'm still listening. right, now, the way these 10, 11, 12, and 13 work, it's the same procedure as what you're doing up here with no problem. Number 12, you just have to realize that that is the same thing as all right, you just have to realize that, and then you can fool it out. Same thing with 13. But if you were to go and actually look at the book in, what is it? Is it 5 point? In 5.4, they call it something like special forms or something like that. And these 10, 11, 12, and 13 are called special forms. Excuse me. I'll have to put on my jacket here. All right. So no problem using FOIL on 10, 11, 12, and 13. You just got to remember 12 and 13, that's what the square means. 14 is just a binomial times a trinomial. And the only really rules are you just got to do the same thing you did for FOIL. And then you're going to multiply the 3x times all three terms separately. And then the -2 times all three terms separately, which means you're going to have 6 terms now. And then you're going to have 2 sets combined. And in other words, it'll collapse into 4 terms. Sorry, it'll collapse into 3 terms when you combine the 2 pairs that are alike. Because you'll have 2 x terms and then 2 x squared terms. But this right here, like I said, it's almost like if it were me, I would just almost not mention this. But I'm just going to show you. This is what we call the difference. If you go on to take Math 130, this could be important. And then this one is called, both of these, 10 and 11, are difference of squares. This is what we call the sum. And why it's called the difference of squares, see, you have an x minus 3 and an x plus 3. Everything is exactly the same except for that difference in sign. Well, if you look at the form of this, I'm just going to make up a general one with x plus and x minus y x plus. Then what you end up with is this. I got to put the little x squared minus y squared. So if you recognize that this is a difference of squares, like this one and that one, then you can simply do this. You can say x squared minus 3 squared, and then simplify it, which is x squared minus 9. Well, why does that work? Well, let me show you. Let's just do the FOIL on it. X times X is X squared. X times 3 is plus 3X. Inside is negative 3X. And then the last, it's negative 3 times negative to positive 3, so it's negative 3 times 3. So what happens here? You got X squared, and you got a plus 3X and a negative 3X. These are gone. They cancel each other out. So all you're left with is X squared minus 3 times 3, which is 9. So that's why this formula works. We can also, and I'll do this one down here, and then we'll do it by FOIL, because this one's a little bit harder to see that. And I mean, I just say this because, you know, when I went through math at this level, you know, it took me a while to figure it out. I didn't learn these like immediately. And like I said, there's no way to really say, well, did you use the special form to do this? Well, there's no way to really check that because we can't go in your head and see that. So as long as you got it done correctly, that's fine. But I'm just going to show you the quick way. So it's the first term squared minus the second term squared. So that's going to be 9x squared minus 49 I squared. All right. So let's go ahead and just do it by FOIL then. 3x times 3x. That's your F. So no shame in doing it like this. Outside and then negative 7y times 3x. That's the inside. And then it's going to be hard to squeeze it in here, but negative 7y times 7y positive. All right, so what does that give us? 3 times 3 is 9. X times x is x squared. This right here is 3 times 7, so that's plus 21 xy. Inside is negative 21. And then the last is negative 7 times 7, so that's negative 49. Y times y is y squared. And look what happens. Again, these two are exact opposites, so they take each other out. Canceled out. That's where the term cancel has its true meaning, because they're no longer there. There's nothing there. All right. Well, I tell you what, why don't you do 12? Probably I should have let you go ahead and do them before I explain. Go ahead and do 12 and 13. That one's a little bit more difficult. That way that works. And I'm not going to do that right away with the form. But let's just see how you get, how it works for you. When you get something like x squared plus 14x. Let's see if somebody else comes up. Okay, we got a second. All right, so let's see what happens. X times X plus 7 times X plus 7X plus 7 times 7 All right, so X squared plus 14X plus 49 is correct. Now, here's the thing. The special form is rather a little complicated here. I'm going to write it out up here. All right, so I'm going to put it up here. I'm just going to use X plus Y to make it kind of generic. All right, we'll get to number 13 in a minute. But I just wanted to show you this form because it just gives you an alternative way to do it. Anyway, okay, so you're essentially squaring the first term right here. And then you square in the last term, it's on the end. And the middle term is taking these two, the X and Y, multiplying them, and then multiplying them times 2. So that's why we have 2XY right there. So this to kind of show you. X squared. And in the middle, we're going to have 2, the little square thing is going to serve as a 2, times 7x. Oops, yeah, because it's 7 times x. And then it's the second one squared. So what does that give us? Same thing. The reason why you can do that on these is because they're going to follow that pattern. The other ones, the ones that we looked at, just the individual ones, the ones that weren't these special forms, there's no way to determine what they're going to be. But with these, they're following that form because we're squaring. We know there's exactly going to be 2 terms that are exactly alike. See, there was 2 there. So instead of writing them twice, we just write 2 times the product of 7 times x, and then square the ends. All right, let's move on down. And look at the one that is, of course, going to be a little bit harder. All right, now I'm going to do it down here, and then we'll FOIL it. I'm going to do it the short way down here. All right, it's 4x squared. It's negative, so you got to bring that sign there. And then I'm going to put that 2 there. And then it's 4x times the 9. Because I've put the sign here, that's going to be the, because it's going to be middle. And then it's plus that squared. And the reason why it's going to be plus is because negative 9 times negative 9 is going to be positive. So let's see. So this is 72x plus 49, not 49, sorry, 81. All right, now let's go back and do it like the way that probably most people are going to try to do it. And there's nothing wrong with this. Like I said, I just wanted to show you that there is a short way for this one and that one. Well, all of these have their short ways, but unless you recognize that, it's going to be hard to do it. Like I said, it takes some experience. Unless you're already pretty good at doing these, you might not be able to figure that out. So it's 4x times 4x. I have room for that. And that's a negative 9. Minus 9 times 4x. There's just a difference in order there. Those are the same things. Plus negative 9 times negative 9. All right, so 4 times 4 is 16. X times x is x squared. All right, and then on the middle one, it's going to be positive 4 times negative 9. So that's negative 36x. This is the same thing. Negative 9 times 4 is negative 36x. And then it's negative times negative, which is positive 81. So what happens? You got those two in the middle. Same thing. No problem. So if you understand this and you're doing pretty well, one of the things to try, like I said, it's not something that really anybody can check for. They may like give you some kind of general question, sort of like these here and there. But that's about the only thing they can do. But you could easily just multiply those out and get that. All right, let's see. I actually had done one here. All right, so let's clear this. So you don't we don't spoil the surprise. Was it? I think that's it. Yep. All right, so there's no real monomic for this like FOIL. You just have to multiply the 3x times the 5x squared times the negative 2x and then the 6, and then come back and do the negative 2 times the other 3. So I'm going to give you a chance to try it out. And then I'll go through it with you. And like I said, that's the last thing we're covering for this chapter. I mean, for this, yeah, for chapter 5. So up until this point is all the midterm stuff. And really, like I said, I don't know why I had in my head that 5 was a little bit more complicated. It's just basically using those rules about the the exponent rules in several different ways. All right, let me know when you get something. All right, anybody coming up with anything yet? All right. It takes a while, doesn't it? I'm surprised y'all haven't gotten anything. Let me know. All right. Oh, I'm seeing it. Not on one. It's not showing over here. Okay. All right. So let's just do it. And like I said, I'm just going to kind of multiply them in order. All right. There's the first one. And then plus 3x times the middle one. So there's the first three, and I'm just going to keep on going because now I'm going to use the -2 times the first one. So 3 times 5 is 15. X times x squared is going to be x cubed. Again, we're using our product rule. 3 times -2 is -6. X times x is x squared. And 3 times 6 is 18. X. -2 times -2 is +4. 1x. And then -2 times 6 is 12 negative. 1, 2, 3, 4, 5, 6 terms. Now, you'll notice there's 2 pairs now that go together. Those 2 and these 2. So let's put them together. So -6 and -10 is -16 x squared. 18 plus 4 is 22. And that's just regular old plain x's. And then the -12 is by itself. Okay, well, we're pretty much finished. So if you got any questions, just go ahead and shoot. I don't really have anything else to show you. This is the midterm review. If all else possible, make sure to do that review in my math lab so you bring back any questions you got, all right? It's going to cover everything from the beginning, although in a sense, you know, you're always doing the same things here in chapter 5. It's everything else we've learned so far. The only thing that's kind of really different is the graphing. There's some different things there, but you know, this stuff, my math is cumulative just by its very nature. So just we'll go over this. It's in that same place everything else is. Right there, okay? Midterm review. And let's see, it's 4 pages, 5 pages, a little bit of everything, okay? Last 2 pages of graphing, and then the graphing of the inequalities. You got to figure out the lines, the equations of the lines, both in slope-intercept form. And then this is the stuff that we were just doing here. Plus there's formulas and then a couple applications. And then this right here is, again, some of these things are from the same chapter. Like I said, since math is kind of cumulative on its own, there's not a whole lot to show from like chapter 1 because that was where we just talk about numbers, but they might have something like that. I don't see anything that directly relates, but like I said, we're always doing stuff that's in chapter 1 and chapter 2 throughout because that's all that multiplying and dividing and collecting like terms with numbers. and then variables. All right, well, I'm gonna